I'm almost done. Give me one moment. This always takes me a couple minutes to do. If you're just joining us, would like to learn, where are you from? Where are you located? Are you here in so where are you located? Are you located in Europe? Are you located in the US? The room is getting really full. Hey, good morning, John. Always a pleasure to see you, John. Thank you so much for joining us. Appreciate it. John is one of our regulars, and his input is always extremely important for us. So I greatly appreciated you being here, John. Always nice to hear you. Oh, all the way from Africa. Thank you so much for taking the time to join me today. Greatly appreciate it. I'm going to go ahead and start the webinar. Let me just go ahead and start sharing my screen, and we'll go through a couple slides before we actually begin, and then we'll go live with Eagle before we start our webinar. So as many of you already know, we host this webinar. I would dare to say we do it actually once a month. We do the first one, the first Tuesday of every month. The second Tuesday of every month, we do getting started with the schematic editor. And then on the following Thursday, we actually do the PCB layout editor. Okay. So let me just go ahead and start sharing my screen. If I get to that point. Share the screen. Start sharing my screen. There you go. Now I'm sharing. Okay, just let me know if you could see my screen. If you don't mind, just let me know if you could see my screen. Oh, hi, Manoj, from China. I won't be able to monitor our friends from our YouTube page. I'll try my best to join that page as well. That way I can monitor those that are joining us via live stream. Okay. Yes, I'm able to turn that one on. Okay. So yes, a welcome to all of our friends joining us through our YouTube channel. I hope all you guys are doing well. Thank you for joining us, and love to know, like to know where you guys located, where are you from? So if you don't mind, and if there's any questions on the YouTube channel, you could always just put them there, and I'll eventually get to them. Okay. So those of you that are on our YouTube channel as well. Okay. Okay. My screen is visible. I have a confirmation. Thank you, Manoj. Thank you, Eamon. Appreciate it. And oh wow, from China. Excellent. Well, you know, as I was saying earlier today, oh, let me hit the record button because marketing likes me to record these sessions as well. So, thank you for taking the time to join us again on our webinars. Today, we're going to be talking about getting started with Eagle. And today's part one. On Thursday, we'll do part two, which we'll be working on the schematic editor. I ask you to refrain from asking questions throughout the session. I'll address your questions in your Q&A at the end of the presentations, if you don't mind. Now, you could use the chat or you could use a Q&A, whatever you feel comfortable with. Now, my name is Edwin Robledo. I'm part of the Autodesk support team as well as a community manager. And maybe later today, Jorge Garcia will be joining us as well, which is also a support specialist as well as community manager as well. We've been working with Autodesk Eagle Combined maybe for approximately 30 years. We're working with CAD Soft Computer, which was the initial creators of Eagle, and then we've been able to transition over to Autodesk as well. And they've allowed us to now continue working with presentations and classes for the community as well. Now, I just want to give an overview because I did see that a large percentage of our users were starting with Eagle recently. So I just wanted to go over a little review. So Eagle basically is a platform that consists of multiple editors. Okay, it's a whole bunch of editors that are linked to each other some way, somehow. So the first thing we're going to be doing today is working on the schematic editor. The schematic editor is the blueprint representation of a circuit board. In other words, the schematic uses particular symbols as well as shapes for those symbols that represent components that have a particular behavior. Not all components have a specific representation shape because it's just too complicated because there's so many electronic components. But as you see in my little example here, you know, the little squiggly lines, the capacitor, parallel lines are, I'm sorry, these are resistors, parallel lines are, you know, capacitors and so forth. It's kind of like the blueprint of the circuit board. Now on the schematic editor, you're not really taking into consideration the physical aspects of the circuit board. Here you're talking more about the connectivity, kind of like the logical part of the design itself. How is it going to function? Now, the other editor that Eagle actually work, and they work in conjunction really well, and that's the board layout editor. Now, in the board layout editor, now you're taking into consideration more of the geometry of the circuit board itself. Now, the components that we're using on the circuit board are called footprints. Now, footprints refers to the amount of copper landing that needs to be on the board. That way you could solder the component. So it's not really the component itself we're working on. We're talking about the amount of copper that needs to be placed on the circuit board. That way I could solder the component itself. Now, these specifications are usually provided by either they following a particular standard like the IPC standards, or the manufacturer will give you the specifications for the components they plan to use as well. Now, the other editor, those components that you need in your design, you're going to be acquiring them from something called libraries. Libraries is basically the building blocks of anything that has to do with electronics. The application is only as good as how many components it has, or if it has something called an editor, that way you could build your own components. Well, guess what? Eagle has maybe one of the easiest, nicest workflow component editors there are in an ECAD application. Our library editor, you're able to create the schematic symbol, which is a logical representation that's going to show up on the schematic. And then we have our footprint editor, which is actually the aspect in which you're going to take into consideration the physical aspects of the component, how much copper material needs to exist on the board. That way you could solder that part to the board, which is referred to as a footprint. And third and final stage is actually you put it all together. That way when you're working from a schematic to a board. Now, today I'm just going to go over just a little bit over the control panel. That's the first screen that comes up. And I did notice that 60% of you actually learned about today's webinar through the control panel. So you're already familiar a little bit with the control panel, what it does. But I'm going to go over it just a little bit because there's a few aspects I would like to point out of the control panel. And then second of all, we're going to actually be working with a schematic. We're going to go ahead and create a project. Then from that project, we're going to create a brand new schematic, and we're going to constrain our working area by actually placing a frame. You don't have to always place a frame, but it's just for documentation purposes, it's always really good idea to constrain your work area by defining actually a frame or using one of the frames that Eagle already has. Now we'll place our components on the design. A very simple component. It's only going to include a handful of components as well. And then we're going to go ahead and define our connections using the net command on those components. Okay. At the end, we're going to end up with a really nice, good schematic, all connected. And then we're going to run ERC, which is an electrical rule checker. Now, ERC is not a simulation by no means. It just gives you warnings and errors. Let's say you connect VCC and VDD together. Well, that might be actually a good connection, but it's gonna let you know that you have two different supply signals actually being connected, and it's just gonna warn you about that. You actually may want to have that connection, but it's gonna give you an idea that those connections are not intended to be together, and it's gonna warn you about it. It's not gonna stop you from not doing it, okay? And from that point, we'll create the circuit board, and I'm going to end there. And then at that point, I'll continue on Thursday, and then we'll have a Q&A session after that. Okay. So let's go ahead and move on to the to Eagle. Go live with Eagle as well. Oh, hi, Fox. Nice to see you. Thanks for joining us again. Greatly appreciate it. I hope everything is going well for you as well these holidays. While I do this transition, I'm just going to turn on my video roll for a minute. That way I get to meet you. Hi, everybody. I hope you're doing well. So let's go ahead and move over to Eagle. Okay, excellent. Well, now we're going to go ahead and share my screen again. That way we could begin our demonstration of how to use Eagle. Well, when Eagle is available in Windows, Linux, and Mac, and the interface is exactly the same throughout all three operating systems, okay? Now, in the control panel, we have two main tabs. One is called our Home tab. Here you're actually going to be able to take a look at the future webinars that are coming up as well. Some of the latest projects that you've been working on. Okay. Actually, the most recent files are actually up here. Most recent schematic and board files that you've been working with. If you've been generating 3D step files from your designs, those are going to appear there. Okay. And to get the latest news of Eagle. Okay, there we go. You'll get them down here as well. Right here. You get always the latest news about Eagle as well. Okay. Very well. Now, the first thing I want to do is I want to work with with the libraries. You know, as I stated earlier, the libraries is kind of like the foundation of any electronic design. Okay. And here in the control panel, we could expand the library tree, as you could see here. These are all the different libraries that actually I have with Eagle. So let me explain all these folders that you see here, which is might be a little confusing. So these that you see with the persons, the icon that you see with the persons in there, you see those icons right there that has like a little person in there. That just means that those are managed folders. And the managed folders basically contain libraries that are being shared with me. For example, that first one that I have here called Common Folder Team 1, that's just us here at the support team in Eagle, which we have members in Germany as well as here in the US. We like to share a common folder in where we could actually share our libraries. That way, if we're working with multiple projects, we're actually making sure that we're getting our components from the same repository. So as you can see here, this is one that I have with team. This is the one I have with Matt that I'm actually sharing with Matt, which is our director of development for Eagle here in Autodesk. And these are my libraries. These are libraries that I have created. Somehow I built these libraries, and they have the little sign there because I may have shared them. And that's why they have that sign. So I may have shared that file. Some user files, some that users actually share with me. That way I could troubleshoot um, some of their designs. And I also have this one here, what says managed library. That's our default library. When you install Eagle, oops, sorry about that. Go here, okay. So where it says here managed libraries, I'm gonna go ahead and expand that. And these are all the libraries that come with Eagle. There's a lot more, but are actually being shared with us by, how should I say, by distributors or manufacturers, okay? So we have TE Connectivity, which is a library that is being shared with us. And this is shared with everybody on the community, okay? We have the ones from Adafruit, which are Limo Fried. She's sharing her libraries with the community as well. And you could just download these through the library manager. And how you actually download them is actually pretty simple as you go. So give me 1 second. So when you're going to share these libraries, in essence, is you go to here, Library Manager, and here's actually where you're going to decide which libraries you want to share or which libraries you actually want to put in use. So basically what I do is I go here, I do a right click, I go to my library manager, and I tell it exactly which libraries I'm using and what libraries I intend to be using and make them available at the stage here. Okay, that's what the library manager does here. Now, you'll notice that I have many libraries here from different users. And here where it says Eagle PCB, I'm going to expand that tree. These are the default libraries that when you install Eagle for the very, very first time, these are all the libraries that show up, as you could see. It's like 300 libraries, and each library can contain between 5 to 40, actually to 100 components. Now, please I want you to take a careful look at this dot right here. These gray dots. Okay. I could change their status by clicking on the dot itself. As you could see, I could turn it green or I could turn it gray. What that means is that that library is in use. In other words, will that library actually show up on my schematic when I need to use components from there? If it's gray, it will not show up. If it's green, and that library will actually show up. Okay, that's what that status bar means at that moment right there. Okay, so since we have hundreds of libraries that come with Eagle, there'll be designs that you just don't need all those libraries. They're not necessary. That you just don't need all. You don't need 100. You don't need hundreds of libraries to select from. Okay, so what you do is I'm going to actually select those libraries that the only ones that I wish to appear. Now, these are all the libraries that came by default with Eagle. And if I wanted to use anybody else's library, I'll expand. Let's say I want to use the ones from SparkFun. I could expand that, and I could say I want to use the aesthetic library or the batteries library or capacitors clocks by SparkFun. I'm sorry about that. Now that we've covered the libraries, and you'll see that I've already selected what libraries I wish to use. They're here in green, as you can see. Okay, so I have that one, this one, and I have some other ones down here. Those are the only libraries that I actually want to see, for my design right here, as you can see right there. Okay, now, in addition to seeing your libraries, we have our design blocks, which are like for design reuse. These are sub-circuits that you could actually be using if you wanted to add it to your design. Sometimes, always the schematic editor is already there. Then we sometimes have the board layout already laid out as well. Now, the majority of design blocks are only going to be consisting of the schematic editor. Now, some of them will include the board layout as well, okay? Very well. Now, we have user language programs, scripts, CAM jobs. If you're actually going to be using any of our SPICE models, you'll find them under here, under our examples file. Those are different if you want to use our NG SPICE assimilation tool. Now, I don't want to continue more with that because I actually want to go into the design time. I want you to show you how to actually use Eagle and design your very first schematic. What I'm going to do is I'm going to expand the projects folder. Okay, these are different projects that are currently that are available. On the projects folder, the main one right here. Now you'll notice that all these folders that you see here are going to be, their path is determined where you have your options directories right here. So all my projects are determined here where they're going to be located. Okay, this is where all my projects are going to be. So I could actually change the path of where my files are going to be located for my designs files as well. Let me bring up my Finder. That way you can see exactly where they're located. So in my case, I put my Finder at. Okay. So Eagle is going to actually, you see it says Eagle and projects. And as you can see, these are all my projects that I have here. Okay. And I have more projects over here, projects too. Now these are the projects that are showing up right here in this folder right here as well. Okay, so these are my projects that I have, my swing arm, as you could see, swing arm test 2 and so forth. So this is the path for where my actual designs are actually located. That's what this is. So as soon as I create a brand new project here, it's going to show up on this path here automatically. So I'm going to create a brand new project. So I'm going to right click. I'm going to select project. Now that the project has been created, okay, which is kind of a subfolder. The nice thing is that when it's a project, you'll see that it acquires that green dot right there. That means that that's going to be from now on my active project. Okay, so when I'm working with Eagle, it's always going to be making reference to my active project. Okay. I could turn on our projects automatically by clicking on the red dot, and it will automatically disable this project and activate the other project. This just makes it that it's going to automatically open up that schematic and that board as well. Now that I've created a project, but it's empty right now, I'm going to start creating my very, very, very first schematic. I'm going to go ahead and right click it and select new and select the option schematic. And now we're in the schematic editor. The layout of the schematic editor can vary depending of how was the last time, if you had Eagle already installed, how did it look in the previous time, and how you've set up your screens. Now, this is basically the toolbar on the top has, let me move this menu out of the way. As you can see, we have our icons on the top, which have to do with the zoom, if you want to execute any scripts, if you want to access libraries from here as well, which we're not going to do right now. And then we have our action toolbar. These refer to all of these are our spice tools if you want to do any type of spice simulation with Eagle. Here it actually let us know what is our active layer right now, which is the net layer, which should be the right layer that we have assigned at this moment or have active at this moment. Okay, and then we have our grid as well as our layer settings now. Okay, now you'll notice that the icons are grouped on the left-hand side. They're in small groups. That's according to how often they're actually being used, as well as we wanted to do it as logical as possible. Now, if there is one rule that I need you to really, really pay attention at this point, is that when you're working on a schematic, it's very, very important that you only use a 0.1 inch grid on the schematic. If you ever use any other grid to place your components or to create your connections, it's quite possible, or you could use, of course, the equivalent in other unit systems. But there's a good chance that if you vary from the 0.1 inch grid, your connections will not work. Okay, because when it comes to the schematic symbol, all of the components that we build, as well as the template system that we use which is an IPC package, a compliant package generator, we always use the 0.1 inch grid. And the reason we do this is because we wanted to be consistent, less prone to error. And on the schematic editor, you're not really taking distances into consideration. You're not taking measurements that much into consideration. It's more about the logical flow of your design. So we're only working with 0.1 inch grid. So please, if there's anything you take out of this webinar, please remember that you always work on the schematic. Now on the right-hand side, now on yours, it doesn't have to be on the right-hand side. I've tabbed them all on the right-hand side. I have my sheets. If I have multiple schematic sheets, that will appear here. Here's my inspector. If I have any components or any item, any asset selector, assets selected, they will actually appear on the inspector. I'll get additional information here. My selection filter, this lets me decide which components or which assets of my design I want to select. Let's say I only want to select devices. I could go here and just select devices. I guess I don't have any there, but I would actually be able to tell it that I only want to select attributes or only junction points. And I could actually tell it I only want to select junction points. That way it will ignore anything else that is in the area. Okay. So here I could determine and say exactly what I want to select from. And then we have our design manager, which we actually hosted a webinar last month only on the design manager because of the multiple amount of uses to use. So the first thing we're going to do on our schematic is we're going to determine our workspace. Okay. You notice that I have a cross here on the bottom left-hand corner. That's my 0, marker. As you move your mouse cursor, you'll notice that these coordinates change right here. It's just letting you know where are your mouse cursor on the workspace that you're on. Now we're always going to work on the positive quadrant. We really don't want to work with negative. Now, you can work with negative coordinates if you want to. We just avoid it to avoid confusion. Okay. So the first thing I'm going to do is I'm going to add a frame. So I'm going to click on the add command. Eagle actually does include multiple frames with it already. So I'm just going to use one of them that we already have. So I'm going to click here on the add command. And these are the only libraries that I actually have placed together. Okay, I'm only using these libraries. I'm not using any libraries. Remember, I told you that we have over 300 libraries, or actually even more, but I'm only going to put in use these like 6 or 7 libraries because these are the ones that I need for my design. I don't want to have to fish through all those other libraries. I'm going to expand the library tree. As you could see, I just moved that little triangle there. Now, for our friends that are using Linux, these shapes might be just slightly a little different. They might just be a little different, these shapes, but don't worry about it. The functionality is exactly the same. So you don't have to worry about it being any different, okay? In Mac and in Windows, it uses the same one. And on Linux, it really changes because it all depends on what distribution you're using, okay? But it's exactly the same thing, okay? So here I'm gonna actually use the frame called, I'm gonna use a letter L. No, I actually wanna use, I like using frame AL because it's letter size and it's in landscape and it does include the information box as well. So I like actually using this one. We don't have a bigger plotter, so I'm just gonna go ahead and use that one. You notice that the frame now has appeared attached to my mouse cursor. The frame was built in a way that the bottom left corner of the frame is actually the origin of the component as well as the handle. I'm using my mouse wheel. Even though I'm on a Mac, I'm using a PC-based mouse because I like having the scroll wheel. Now you could use the pinching system if you're using a trackpad. So I'm using here to pan back and forth just to get zoom in and zoom out. Now the pan, I'm press and holding the center mouse button. That way I can pan on my screen, as you could see. I'm not moving the component, I'm panning the entire screen, okay? I'm gonna place my frame or handle directly on the origin of the page, which is that 0, 0 crosshair that you see right there. Now place one, and you'll notice that automatically another one appears on my mouse cursor. Let me do a zoom to fit, that way you can see what's going on. This is the zoom to fit right there. And you'll notice that you automatically get another one here. In this instance, since I'm only using one, I'll be using only one frame for this design. I'm not using multiple sheets. I'm gonna go ahead and escape to this, but it's useful that way you get automatically another one on your mouse cursor, because if let's say you're using discrete components and you select the resistor, automatically the next resistor is going to appear and then the next resistor. So every time you place it, you'll get that same component again attached to your mouse cursor. Now, how do I get back to the add command? I have a couple options I could do here. I could either go here back to the add dialog box if I want to, or I could hit the escape key and it will put me right back to the add dialog box. That way I could go ahead and select my other components. Now for my design, I actually need to use a 555 timer. And I don't see that I have the linear library here selected, which is kind of a shame. I got to go back to my control panel because I do not have the linear library here selected, where I'm actually going to get my 555 timer. So let me show you what those results would be. I'm looking for the linear technology 555 timer. I'm going to hit asterisk. Now see here, I'm using the search function that I have down here. Okay. And I have all the options turned on, pads, SMD pads, and it's actually going to look in the description of the components. I'm going to be using the wildcard because if I don't use the wildcard, it will only look for components that have the sequence 555 3 times, and that's it. They have to be in sequence. I use the asterisk as my wildcard. That way I could expand the capability of getting more results. Okay, so I'm going to use 555. I don't have any because I don't have a library that is enabled. I'm going to go back to the control panel. That way I could enable that the library I'm looking for. So I could do it directly from the schematic as well. Actually, I'm going to show you how to do it from the schematic as well. So I'm going to click on library, and I'm going to click on so I guess this is a good time to teach you how to use the command line. The command to actually put a library in use is called a use command. So I'm going to go ahead and type use as well. I'm going to type use. This is the command line, as you can see right here. That's the command line. All the commands in Eagle, all these icons, everything like that, all these commands could actually be typed. And hit use, and I hit enter. This is going to bring me to the libraries. It's going to show me the ones I haven't used. See, this is the ones I've used in the design, which is only the frames library. I haven't used. These are the frames these are the libraries I have by default, and the ones that are available are here. I'm going to go ahead and select. I'm going to go ahead and find the linear library and put that in use. This is the library I want to put in use. I'll click in use. And now you'll notice that the linear library is now in use. So I went to available. Okay. Now I have many more libraries, as you can see, in use. This little symbol that you see here means that that library has not been downloaded. It's actually up on the cloud. If I wanted to download it, I could actually download it. Okay, that's just letting you know that it's ready to be downloaded, and it might be expanded. As you can see, actually, it seems that Worth Electronics has been doing a lot on adding brand new components. I had not noticed that they had added all these parts to Eagle as well. In the past, they only had a few components, a few libraries. It seems that they've expanded this quite a bit. So kudos to them for adding so many components to Eagle. So now that we have this linear library actually selected, I'll X out of here and I'll go back to the add dialog box. That way I could add from the linear library. And from the linear library, what I'm looking is for the 5.5 timer, which is right here, which we're going to be using. I'm going to expand this library. Now, on the 5.5 timer, we actually have a couple options that we could use. I could use a surface mount version, which comes up in an SO8, as you could see here. Or I could use a through-hole version, which is this one as well. So I could select which one I actually want to use. I'm going to actually use a through-hole component. Yes, because on Thursday, I want to show you I want to show you something that we could do to easily change this on the board layout. Okay. I'll click OK, and you'll notice it appears on my mouse cursor. Now, I want to position this in a way that it kind of works easier for me. Besides the fact I want to show you some additional commands that you can actually perform with the mouse. So first thing I want to do is I want to rotate this. I'm going to rotate it twice. Each time I rotate it, it's going to come up a 90-degree rotation. Okay, so I'll do a right click once. As you can see, you'll see the rotations up here on the action toolbar. You see the rotations here. I'm going to rotate one more time. Okay. Now you'll see here where I have mirror. I'm unmirrored right now. I actually want to mirror it because I want those pins that are on the right-hand side to be on my left-hand side. And for me to mirror it using the mouse cursor, I'm going to press the middle mouse button. And you'll notice that now I actually mirrored. So I have rotated the component 180 degrees, and I actually have mirrored it as well, okay? A moment, I lost my cheat sheet really quick that I'm following for this demonstration. Sorry about that, let's back up. Okay, now to go ahead and place it, you're gonna do a left mouse click once, and as it happened with the frame, you'll notice that it automatically shows up on your mouse cursor one more time. Now I'm gonna hit the escape key again to go ahead and grab other components that I actually will be needing for my design. So I'm gonna hit escape. Now that I'm back in my libraries, I'll go ahead and clear my search. Now I'm gonna be using a couple of resistors that I need. So I'll expand the RCL library. And I'm using the US symbols, but as you know, our friends in Europe, you could use the resistors in EU format, which is, it's just basically an aesthetic convention that they use in Europe. It's a little different than the convention used in the US. So I'm going to use the US, and for our demonstration, I always like using large components since we do a lot of reflow ourselves here in the office. I'm going to use the 1206s right here. I'm going to use this component right here. Yeah, I'll use that one, the 1206, and I'll click OK. And I actually need 4 of these. Okay, so I'm going to use my route mouse click the rotate it. I'll place 4 of these. I'll put 1, and I need another one. It's kind of like around here and around there and around here really quick. That's almost where I need them. Now the next thing I'm going to be needing, and don't look at the values. You notice that I have not assigned any values to any of this yet. Don't look at the values yet because I'm going to assign those later. Okay, I'm going to hit the escape key one more time, and now I'm going to grab a couple capacitors that I'm going to be needing for my design. Okay, let me grab. I think I need 2 caps for this design. Yes, I need 2 of them. So the same RCO library. Does anybody know what RCO is standing for? If you want, you could use the chat to answer. But, oh yes, I'm going to continue to use the US convention. So I expand the C library, the C US library, and I'll look for some 1206s. I like using Kemet. As always, I like using large components. Does anybody understand what the RCO stands for? Okay, now I'll go ahead and click OK. Okay, and I need a couple capacitors here. I'll put this one here. It's going to sit around here somewhere. Actually, it sits around here. And then this one, I'm going to rotate it because I want to ground it up down like that. Now, the last component that I'm actually going to be needing is I'm going to bring in power. Actually, no, I need a couple LEDs, right? Because the whole idea behind this design is to create a little LED flashing. I should have shown the animation earlier, which this is actually going to be 2 LEDs flashing, and the value of the resistor actually controls how fast they flash. So now I need a couple LEDs. So I'm going to hit escape it one more time. And I have enabled the LED library, and I'm going to be using this regular 5mm bulb LEDs. Okay, nothing really sophisticated, something that you could pick up out of your own shop. I'm pretty sure you have 5mm bulbs sitting on your desk right now. So I'll just grab this here. I'm using the route mouse key to just rotate it a couple of times. I need one here, and then I need one here as well. Now, I'm going to be bringing in power into my design using a pin header. On earlier demonstrations, I was using a battery, a 9-volt battery. The problem is that when I work on the board layout editor, where the 9-volt battery sits on the board, it's kind of difficult to explain because it didn't make a lot of sense. So I'm just going to use a connector. That way you could actually have a 9-volt battery is hook up to a 2-pin connector and plug it into the design. So I'm just going to go ahead and hit escape, and I'm going to use my pinhead library, which I already have enabled. And I'm going to select a 1x2 pinhead, a straight one. Okay, we have the 90-degree bend one, or we have the straight one. I'm going to just use the straight one right now. That is correct, Manoj. Thank you very much. I greatly appreciate it for the answer. So the answer to RCO is resistors, capacitors, and inductors. Okay, the L stands for inductor, as many of you should, I'm pretty sure, know already. Thank you very much, Manoj. Well done. Okay, so I'm going to just put one of those connectors here. Now we're going to hit the exits. I want to stop everything I'm doing right now. There's nothing else I want to do. I don't want to add no more connections. I want to take no more actions at this moment. Okay, so how do I do that? Up here, you'll notice a little stop sign here up on top. So I'll click on that. And when I click on the stop sign now, everything has stopped. Okay, I have nothing going on right now. The next step I want to do is I want to start now adding connections to my design. That's the next thing we need to do. Okay. Now, defining connections on the schematic is by using a command, not wire. It's kind of confusing because a lot of times you're going to want to automatically start grabbing the wire command, and you're not going to be using the wire command. For defining connections on a schematic, you're going to be using the command called net. Okay, that's this icon right here. I'll make a big arrow in that direction. That way everybody could see it. It's this command right there. It's the net command that you're going to be using. That command. That's the command that you're going to be using to define your connections. So let's go ahead and start drawing a couple connections that we'll be needing. So I'll click on net command, and I actually need one that goes from here to here. I gotta just move this capacitor really quick. Move it to the side a little bit. Click on net, and I'll go here. Now, I want you to notice that if I have the net command, and as soon as I get close to the connecting point of a pin, it actually you see a little bubble appears. As you could see, a little bubble shows up. That means that's the connecting point of my pin. I'll left click to start my net. When that bubble appears again, that means I've reached the connecting point of the next component. Now I could left click, and now in my ears, I hear like a little ding sound, letting me know that the connection has been completed. If you're new to Eagle and the connecting point, it's hard for you to find. That's why it's really important that you always work on a point when it's grid. But if you want to, you can go ahead and click on here where it says layer settings, which is also called a display command. And you could turn on a layer called the net layer. The net layer adds a lot of information to your components, but it shows you the connecting point of your pins. As you can see that where that bubble appears, that's the connecting point. The dead center of that bubble is the connecting point of my pin, okay? Let me show you some more parts, as you could see. The only downside of having that layer enabled is that it adds a whole bunch of information on the schematic that you don't really need. It kind of gets a little busy on the schematic. So that's why by default, we have it turned on. But if you're kind of new to Eagle and identifying the connecting point of a component doesn't make sense to you in the beginning, just go ahead and use the layer settings icon to enable that layer as well, okay? I'm gonna go ahead and turn it back off. That way it doesn't look so busy. I'm gonna go ahead and continue making my connections on my design. Now there's one connection that I need to go from the discharge to this trigger area of our schematic of the two resistors here. Now the reason I wanna show this one in particular is because I wanna show you what happens when I cross two nets together. Eagle automatically has, by default, enabled automatically junction points. In other words, when I connect a net with another net and I left click and place the net there, that means that the name of this signal and the name of this signal is exactly the same name. So they're connected. If I was to click on the info command and I select this one here, you'll see that the name of this net is $1 and the name of this net is $1. Therefore, they are connected. Okay. And continue defining some more of my connections that I need. Enable net. Okay. Okay. So those are the majority, a lot of the connections I want to use, but I'll go ahead and continue defining the other ones as well. Please notice the difference here, okay? So I cross this line, there's no connection here. So these two nets are different, but these have the same name, okay? That's the difference. Please make sure you understand that, okay? Now, oh, the threshold. Let me just finish with the threshold and call this a day. Now, I need to bring in power. And remember, I'm going to be bringing in power by means of this, this pinhead that I put here. Now, Eagle does have some libraries that only represent power. In other words, they absolutely have no contribution to the design, to the circuit board design at all. They're only used as rails or to distribute power or to distribute a particular signal. In this case, it's always power usually, to distribute power throughout my design. Okay, and so I'm gonna now go ahead and click on the use command again. And I'm going to go in available, and I'm going to look for a library called supply. Now I'm going to use the supply library, and I'm going to go ahead and put that in use. I'll put that in use. I'll do the add command again. Here's my supply library. In my case, I'm just going to use, let's say, for example, I'm going to use, I'll just use V plus and ground. So here's my V plus. I put one by mistake there. I'll hit escape, and I'll put my ground over here. I'll delete this one I have here. Now, what's going to happen now is I'm going to make a connection between this V plus here. Then what I'm going to do is I'm going to distribute those using the supply, using these supplies. I'll distribute this power throughout the schematic. That way I don't have to run a connection to each one. Give me one moment, this makes sense in a minute. So as you can see, this connection is going to go to ground. This one is going to V plus. Now, ideally, I need to connect this to V plus. I need to connect this to ground. Instead of running a net all the way over here, what I could do is I could make a duplicate here, say copy. I could select this component here, and I could say this is going to connect to ground right here. Yes, so that connects to ground right there. As you could see, that connected to ground. Now this side is connected to V plus. So I'll go ahead and make a duplicate of this one. And I'll say that one needs to drive V plus. Yes, it needs to be connected to V plus. I'll make a duplicate of this one, and this needs to conduct V plus as well here. That's where that's going to be connected. Now you'll notice that I put one pin to another pin together. You don't see a net, but they're actually connected. I'm going to go ahead and use the move command. That way we could verify they actually connected. As you could see, there is a net between them. That actually means that we got a good connection. I didn't have to do that. They actually, when I line up the two pins together, they actually get connected. But just for verification, and I want you to see that as well. Now I'm going to make another duplicate here to this one because I want to, oops. I want to connect it to the V plus that we have here as well. And let's go ahead and connect our ground rails. Now, our design is now fully connected and fully functional. Okay, now, but there's a few things. There's one more trick I wanted to show you really quick. Yes, in case, because it seems to be very, very useful. Let's say, for example, I wanted to put one more component here in between this resistor and another one. I'll just put another resistor. I'm going to make a duplicate of this resistor. Okay, now look carefully that I have a line going from this connection to this connection. Now, if I move this resistor in that same lineup and I left click it, you'll notice that it automatically connects between, it automatically is adopted by that net connected, as you could see right here. okay? It automatically gets that. It's extremely useful, okay? Because sometimes you forget to add a component, and instead of having to delete the nets, you could actually just drag the component into between the nets that are already there, and it will actually be adopted by it, okay? Just wanted to show that because that actually has come up in the past as well. So it's a good tip to know as well. Okay, now the next thing I want to do is I want to start adding values to my components. So my resistors, I'll click on the value dialog on the value here, it says value, and my resistor 1 is going to be a 1K ohm. And my R2 here is going to be 100K. And here my R4 is actually 330. It says 330 ohms, not K, but ohms. And this one here as well. And then my capacitor, this one is a really small value. This is 1 microfarad. And here, this one is tiny, tiny, weeny. This is 10 nanofarads. Okay. And that completes our schematic design, exactly how we wanted to do it. Now, if you wanted to go ahead and turn this on, these LEDs will actually be flashing like almost like once every second, according to our design. I'll go ahead and open up the, this is as far as I want to go. Oh, I wanted to run ERC really quick. So ERC is here on the left-hand side. Let's see if we get, we'll always get some sort of warnings and errors. I'm going to save what I've done so far. So I'm calling it today webinar. And if I was to refresh the screen, you'll notice that the name of the file is automatically adopted by the sheet right there, as you could see. Now the remaining information that I see here, the date gets automatically stamped, the sheet number gets automatically stamped. Now the title of the document field is in blank because we're not using any variables there. So I would go ahead and click on the text command, which is that letter right here, the text command, and I'll put in webinar 2019. I'll click OK. Now the webinar is appearing on the net layer. We actually want that to be on the symbol layer. And we want that to be a little bigger than that size. So let's go ahead and use a larger text, as you can see here, and I'll left click to go ahead and place it. Okay. Let's save what we've done so far. And I'll go ahead and answer any questions to see if you have any other questions. A small doubt, where would we find the connector or switch? And for this example that I'm using right here, I'm using basically a pin from the pinhead library. I'm actually using this pin header. I hope that's the question you're asking. Well, find the connector or switch. Okay, I hope that answers that question. Let me go over here to our friends on YouTube. The properties name and value can be displayed on the schematic if there is a matching keyword in the symbol, like grayscale name and value. Can you make package a keyword that can be displayed? No, not really. A lot of times there is no variable that we have defined for the package at this time. Usually you just click on the drop-down file menu and select the BOM. That will give you which is the package. I'm sure you're referring to footprint, but no, right now, the footprint, you actually will learn which one it is by just going to the properties of the component, okay? Thank you, Ad, for answering that question appropriately about the RCL library as well. Okay, sure, it was a pleasure, Manoj. Any other questions that we have? I know I've gone over a little bit of the time that I actually wanted to allocate to this, but oh, there's a Q&A question here as well. Okay, so the bus feature is a feature in which can be used to be able to carry the multiple names of icon, multiple signal names easily carry them on around a connection. So let me see. Let me make a duplicate of this really quick. Do this as fast as I can. I'll make a duplicate of this component here. And I'll click on bus here. And the alias of the bus, I'm just going to call it bus, is the name of this bus. And I want it to carry signals in $1 and $2 and $7. For example, this is just an example. So now, and this is the name of the bus. Okay. Now what's going to happen is when I click on the net command and I click on the bus, it's asking me which net I wish to use to connect. I'm just going to select N $7, and I'll be able to run that connection to here. It's an aid to be able to drag connections between one schematic from one component to another component. I'll click on the net command again. I'll click on any area of the bus. It's going to ask me which net you want me to select. In this instance, I only selected 3 nets. I select this one here, and now I could go ahead and run that connection. Okay. Very well. I hope that helps you. It's a really, really neat tool. Very, very useful tool. And I want to end with some. I also want to show you a little bit about how to move around on the design itself. So the group command is always active by default, as you can see right here. This is the group command. This group command is always active by default. So if I click and drag my mouse cursor, a group will be selected. If I click and hold on the origin of any of the components that were selected on my group, I click and hold, you'll notice that everything moves with it. Okay, instead of only moving that one, since all of them are selected, it's moving all of them as well. Okay, so I just want to let you know, because a lot of times you want to move one at a time, and it's as easy as creating a group, and just left click and hold on any member of the group, and you can move it as everything as a group. Okay, we have somebody else here. I would like to use the library that have downloaded. Please say how to call the library. So let's go over the libraries one more time. So the add command is the appropriate command to be used to call out libraries. I'll click on the add command. As you could see, I only have a handful of libraries being used at this time. For this design, we only use the frames library, the LED linear, Pinhead, the RCL, the supply library. Those are the only the ones I actually use. If there were more libraries that I would actually like to use, I would click here where it says here, Open Library Manager. Once I open up Library Manager, I could see the libraries that are used in my design, which is in design, this tab right here. In use, these are the libraries that I'm using for my current design, or available are all the libraries that are available in our repository of libraries. Some of them are local, and if you are online, you're going to be able to see the libraries that are online as well. Okay, so I could go ahead and select any library from here if you need it. Let's say, for example, LED driver. No, I'm going to use that one. The microphone. I'll select there, and I could select use it. It downloads that library, and now you see that that library is actually in use right there, as you could see. Okay, and once the library is actually in use, you close this. You close that dialog box, expand that library, in this case a microphone, and now I could go ahead and select the component I need for my design. Okay, Hetal PCB layout is actually an outfit that makes circuit boards, as well as they offer services of creating components as well. And we've allowed them to actually have access to the repository, an account. That way the community can access the libraries that they actually make. And they make a lot of components. They make a lot of libraries as well. I hope that answers your question, Manoj. You should also show where to place library files. So Okay, so a lot of the libraries that I'm working with are referred to as managed libraries. These are libraries that basically are local libraries, but they exist on the cloud, and Eagle works with both of them. That's how these 3D models show up. These 3D models are actually not on your hard drive. They're actually on the cloud. Eagle just has kind of a thumbprint, a thumbnail. That way you could actually see what the 3D model looks like. Okay, a lot of these libraries um, are what they call managed libraries. Now, your local libraries, libraries that are not managed, libraries that you're using that maybe you downloaded from somebody, they're not really managed libraries, they're on your local hard drive. Those libraries are located in your, let me go here, find her. Oh, okay, so as you saw earlier, we have an Eagle folder. And under your Eagle folder, this is in Windows, Linux, and Mac, okay? Everybody, it works exactly the same way. There's no different. On your documents folder, you're going to have a subfolder called Eagle, okay? Everybody does have that, okay? Eagle is automatic. It does that, regardless of operating system. In here, you're going to actually find a folder, subfolder called Libraries. So anytime you download libraries, you should actually put them in this folder, okay? You should save all of your libraries here because this is where Eagle is actually going to be looking for any libraries that you download. Any libraries that you make that are not managed are actually going to be showing up in that folder as well. Okay, that's where those are going to be located. I hope this helps. I would use a library that I have downloaded. Please say how to call that library. Okay, so yeah, exactly. So as long as you put the libraries that you've downloaded, you put it in this folder here. As long as you put them here under Eagle libraries and you put it in there, they will automatically show up when you do the add command. It will automatically show up when you do the add command, or they will automatically show up when you're here at the control panel and you expand the libraries tree, okay? And you expand your folder right here, this one. It's going to have your name. It's going to have your account name, not my name. It's going to have your account name. When you expand this, these are all of my local libraries. These are libraries that I have not managed. These are libraries that I have downloaded, and I put it where I showed you there a minute ago. So let me show you this really quick. See if I could demonstrate this easier for you. Eagle. And this is libraries. Libraries 2. Okay. So all these libraries that you see here are libraries. Oh, I got so many libraries. Oh my God. They're actually in here somewhere. All these libraries right here. That's where all these libraries are located. Sorry about that I have a little bit of a mess. But as I showed you earlier, you determine the path where your libraries are going to be from the Eagle control panel. You go to options directory and you could tell it where to find the libraries. Okay, it's right here. So this is where it's going to find the libraries. So libraries, I got home documents, Eagle libraries. That's where it's looking for my libraries. Okay, that's where my local libraries are going to be located. It gets a little confusing between managed and non-managed libraries. Okay. Okay. I think I've covered everything that I wanted to do today. Seems that I've been able to answer all your questions. Now, remember, you could always contact me at our email address. Let me put it on the chat. That way everybody could see it. So my email address is support.eagle@autodesk.com. You're more than welcome to contact me there. Let me put this over here. Can I increase the intensity color of the show command over a net? In previous version, it was not visible, but in the latest one, it's almost non-differentiable. Yeah, you actually can. It depends what type of monitor you have, but if you go into, let me go into the editor itself, you will be able to now go to, I think it's options, set. Here you have here highlight right here, darker or brighter. You could change that here. Okay, that was just actually, this is a question from one of our friends on YouTube. So Elkin, you could go ahead and go to options, sets, and right there is where you could set up your highlight. Jorge, my colleague, what he likes to do, he actually, his highlight color is actually a different color. So when he highlights something, it actually goes from, I don't know, like from green to yellow. I prefer the highlight, so I actually just increase this value right here. If you have a kind of a 4K type style monitor, you may want to even increase the high contrast a little bit if necessary. You may have to like bump that up as well. To fine tune your display settings, you could also go to options, user interface, and right here you have more options to fine tune. If you have a high screen monitor, a high like a 4K style monitor, you could enable this. I actually do have a high resolution monitor, so I have them enabled as well, as you could see there. Okay, so there's a couple options you could do about that. Okay, Elkin. For those of us that give me Control X. For those of us that join late, will this webinar be available? Yeah, it'll be later. It'll be available most probably later today. YouTube automatically records all the webinars since I live streamed it. So you'll see it within the next hour or so. It should be live already. Okay. If not, you could always email me and I'll send you a link to the recording that I did as well. Okay. And you're more than welcome to email me if you have any other questions or any suggestions as well of other topics that you'll like to see on future webinars. I encourage you to email me. I always, like to get ideas from our users that would like to, learn more and what that I need to cover. Is all the libraries provided by Eagle by default contain all 3D models? No, absolutely. Actually, we've only covered. So the question is, are the default libraries, do all of the components have 3D models? And the answer to that is no. No, actually only a fraction of the components have 3D models. Now, this is this is not really a bad thing. What happens is that, remember, maybe you might not know, but Eagle's been around for almost 30 years. Eagle became part in the market since 1988. Therefore, we've collected an exorbitant amount of libraries, okay, throughout the years since then. So we have hundreds of thousands of components that we've collected through the component. Now, the 3D capabilities of Eagle were added approximately a year and a half ago. So the librarian team, what they've been concentrating is provide you capabilities of be able to create 3D models really easy using Eagle, IPC compliant based components, and we have some other components, some dual inline components and SO components, which can be easily created as well. Or you can map step files to your components as well. Now, they've concentrated a lot in trying their best to the most commonly used components. They've done a really good job at mapping those out with 3D models. But we're not even close to doing all the libraries that come with Eagle. A lot of them are already discontinued. Um, but some of the libraries that come with Eagle, like the ones made by PCB Layout, those libraries, all of them already have like this by PCB Layout, all the components that they make, they automatically map the 3D models to it. So you may want to consider looking at when you're in the library manager, take a look at their parts as well. Now, SparkFun has a really nice amount of libraries, part of the Eagle repository libraries. Now, theirs and the ones from Adafruit are not 3D mapped yet. I wouldn't be surprised that they'll eventually be adding that later on. Okay, so I hope that takes care of that question. Okay, let me see if I have any other questions anywhere else. Well, it's been a pleasure. I get to see you on Thursday one more time. That way we could talk a little bit more on creating the PCB layout. And that's the last step I have it on this webinar. In essence, basically what we're going to do is we're going to convert this schematic. I'm going to go ahead and save it, what we've done so far. And oh, there's one more question I forgot. Oh, I will. Okay. So the question is, they would like to have. They would like to get an explanation of all the sections that are described in the EEL control panel. I'll go ahead and review those on Thursday. I'll come in a little earlier if you don't mind, Eamon. I'll come in like 5 or 10 minutes earlier, and I'll go over that before we start the webinar. Okay, we could go over that. So I usually in half an hour early before the webinar. And just in case you have questions from the previous webinar, you could ask me on there. But that's kind of a loaded question. So it's going to take me a long time to be able to go through all those sections and explain them. But I will gladly take care of that for you. Absolutely. We've done other webinars, which we've only covered the control panel. Um, I will try to put those on the recordings. I mean, those recordings are already available, but we could go over that really quick, though. I could show you exactly what each part means, what DRC means. We're going to be talking a little bit about DRC on the board layout editor as well when we do it on Thursday. Now, going from the schematic over to the board layout editor, it's actually pretty straightforward. Now, remember, I just wanted to bring up really quick the values that I use for this flash LED. Okay, all these values that I use are assuming that you're using a 9-volt battery. Okay, that's how I did it on Tinkercad. I used Tinkercad, and Tinkercad did have a 9-volt battery available, so I use a 9-volt battery, and I to make this. That way I could simulate this on Tinkercad. So it was I use a 9-volt battery for this. Just want to let you know that. Now to convert this over to a board layout, the only thing I would need to do is click on this icon right here that says Generate Switch to Board. It's going to prompt me, do you want to create a schematic? You want to create a circuit board based on this board? I'm going to go ahead and say yes. And you'll see that all the components show up on the left-hand side of an empty board layout. Depending of the type of entitlement license that you have is the size of this board. So if you have the standard edition, it'll come up with that size of board. You have the premium edition, it will come up with this size of board as well. If you have the free version, it comes up with a little bit smaller of a board area. And then from this point on, we'll start moving components in here. We'll put them on the top, put them on the bottom. We'll define some polygons and so forth from that point on. And I'll go ahead and cover that on Thursday. Well, thank you everybody for joining us. Everybody is kind of like has stayed online. So I want to make sure I cover everybody's question. It's been a really nice the room got really full. I didn't expect it being in December that it would be this packed, but I'm pretty I'm pleasantly surprised how many people actually showed up. So this is great. I really thank you for joining me. Everybody have happy holidays. Have a really nice time, and I get to see you in one day. I'm really lucky enough that I get to see you in 2 days. So I'll see you on Thursday afternoon. Please join me again. And any comments, suggestions, or ideas, please email me. I'll put it off for our. I don't think I put it for our YouTube friends as well. Hey, Fox, thanks for joining me. I appreciate it. And John, as always, a pleasure seeing have you here with us as well. Let me see if I spelled that right. Thank you very much, Elton. Greatly appreciate it. Elton, I hope I answered your question, but if I did not by any chance, yes, go ahead and email me at support.ego@autodesk.com and I'll gladly address any questions that you may have, okay? My name is Edwin Robledo. It's been a pleasure to spend some time with you. And those of you that are joining us from Europe, hey, thank you very much. I know it's a really weird time for you, um, but always keep track of our webinars. My friend and coworker Rick out of Germany, he does his best to run them like once or twice a week himself. Sorry, a month as well. So keep an eye out for his webinars. The webinars that are hosted in Germany are in German. The webinars I host are in really bad English because my German is non-existent. Um, so I'll do those in English. And I promise for my friends in Latin America, I will be scheduling some Spanish webinars as well. I know they've been contacting me, but I will do my best to contact you. Okay. Um, yes. Oh, okay. Hey, Michael, thank you for your comments. That's really nice of you. Very kind of you to put the comments. And make sure that you have all sorts of fun with Eagle. And for those of you that are still, I have one more surprise for you. In the Eagle command line right here, if you Go here on the Eagle command line right there. From the board layout editor, just go ahead and type the command snake and make sure that you get a high score. Okay, so just go ahead and type the command. Just load one of our demo boards if you want and type the command snake and you'll see a really nice surprise. I like to leave that for the end for those that stay with us all the way to the end. Thank you very much, everybody, and have a great day. And Michael, design something that makes everything better for us in this world. I appreciate it. Everybody, have a great day.